night, you were supposed to read the first part of chapter 3, just like the first few pages. And so in that first part of chapter 3, you should have read about a lot of things that you're familiar with, right? You've read about pie graphs and bar graphs, right? You've seen those before. You know how to create those. That's nothing really new. I do want to go over some vocabulary, some things you read about last night, and then I'm going to go into some new things at the end of this that you didn't read about. Okay? First of all, I want to make sure you know the difference between frequency and relative frequency. It's not really a big deal, but you need to make sure you know the difference. A frequency is an actual count of something. So there are 5 males in this class and 4 females, right? That's a count. That's a frequency for each category. A relative frequency is just the percentage version. So don't be tripped up by the term relative frequency. It just means the percentage. Does that make sense? Right. So they use a fancy term for meaning they want a percentage. Does that make sense to everyone? Make sure that you know that. Then it says you can describe a distribution of a categorical variable. The distribution just means you can either write it as a frequency or relative frequency. If it's talking about eye color or whatever, the distribution would just be the number of people in each eye color or the percentage of people in each eye color category. That's all distribution means. Okay? Nothing fancy. Just the separate categories. Out their totals. Also, you read about the area principle last night. You saw the big graph with the Titanics that were blown up. Yes, the length of the Titanics was correct with the frequency, but the actual Titanics were enormous and then really small, right? Here's what happens. People think that making their graphs cute is more important than making their graphs easy to read, all right? You want to make your graph as boring as possible in that it's 2D and it's flat and it's easy to read so that no one gets a misconception about the actual category. So an example of the area principle here, I've got a box, 70% versus 30%. The little box is not 30% of that big square, right? So that's misleading. Make sure that you just have flat 2D things. Don't try to use fun graphics. It always turns out badly. All right? So, here are some things about graphs, okay? You can always, 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 always see a misleading graph somewhere, I promise. You always need to be skeptical of what you see. In fact, I would just tell you to trust no one, okay? There's just no point. I'm about to show you a series of graphs. Some are from our textbook, but most of them are from newspaper articles or television. So things that people would just see on the news. You know how they show graphics on the news and they're up there for like 30 seconds and they take them away? So if you don't really get a good chance to look at it, you just go with whatever it says. Don't do that. All right. So there's some about the area principle. There's others just about misleading information. It may not be categorical, but it's just important to note some misleading information. So here we go. This is from Fox News, 2012. What's wrong with the pie graph? Way more than 100%. So that means probably whenever they did whatever survey they did, you could pick more than one person. Well, that doesn't help anybody because if you're doing categories, you need to fit into one category. All right. So, but if they just threw this on the TV, hey, it looks good, right? So make sure, again, you're watching out. Exactly. The section's all the same size, even though the percentages are different. I'm telling you, people just put stuff on TV because they think they can. All right, the next one is also from Fox News. I'm not trying to pick on Fox News, okay? I really am not. Here's one about the cost of gas. What do you notice that might be a problem with the cost of gas graph? The intervals. What are the intervals? Last year, last week, and current. What happened between last year and last week? Well, gas probably did this between last year and last week, right? So do not just trust 3 data points. That doesn't make any sense. But again, it was on the news. So All right. This is one from our textbook. First of all, we've got 3D bars, which people think are really cute, but it can be misleading. And then what else might be wrong with this? It's the number of airline passengers they searched over time. Yep, you have 1 year intervals after you've had 2 year intervals. You can't change your scale. Doesn't make any sense. Here is a bar graph about knuckleball velocity, 2012 versus 2013. But if you notice the miles per hour, you have 77.3 and 75.3. There's only a difference of 2 miles per hour, but it looks like this guy sucks now, right? So, yeah, people can, sure, people can, this is why people in advertising love their jobs. They can do whatever they want to make you believe whatever they want, but it doesn't have to, if some people don't want to look at a graph, they're like, oh, that looks terrible. If you actually look at it, though, no problem. Okay? No. No, just some bars. Yeah. Here's gun deaths in Florida. Number of murders committed using firearms. If you're looking at it, it looks like over time that it's increased and then decreased and we've gone up again and gone down, except that the scale is upside down because that's what they wanted to do. So they're actually proving their point, but it's hard to read. So, right. So they're saying that after their stand your ground law was instituted, there was more gun deaths in Florida. So that's, I think, what they were trying to prove their point here. But you have to make sure you read the scale. Normally, you don't have a scale that goes from the top down, you go from the bottom up, right? So, again, make sure you're looking at things. And then the last one. More than 98% of all Chevy trucks sold in the last 10 years are still on the road. This was an advertisement. Yes, that looks terrible. But if you look at the scale, it's 95 to 100%. So, yes, so like Nissan trucks are already at like 96%. Again, advertisers just do what they want. So, you can do whatever you want with data. It's your responsibility to make sure that you know what the data is about and what the data is doing. Okay? So be careful with graphs. It's important. All right? Okay. So that kind of covers what you read about last night. All right, we've got relative frequency, you know that's percentages, area principle, any type of graph, make sure that you know what's going on. I'm not really going to go over pie charts and bar graphs because I'm pretty sure you can make them. Right? Yeah. Okay. There was also relative frequency bar graphs, which are the same thing. It's just based on percentages instead of a count. It's the same thing. All right. So here's the next part of chapter 3. Still talking about categorical data. You could have categorical data in a two-way table. So you read the big intro to chapter 3 last night. You know it's about the Titanic. That's what they're going to talk about. So here we have a two-way table about the Titanic. All right, we have survival and we have class that they were in. Right? A two-way table in our class is going to be called a contingency table because one variable is contingent on the other. But it's just a two-way table. You guys have seen a two-way table before. It's nothing new. All right? But again, some fancy vocabulary that you might need to know. If they ask you about the marginal distribution of something, we talked about the distribution earlier just being the number of people in each category. In this case, the marginal distribution are just the totals. That's all it's asking for. You can report that in percentage or just as a value, but marginal distribution just means the total. Some tables don't have the totals on there, so you need to find them by adding the columns of the rows. That's all it means by marginal distribution in fancy terminology. Okay? Now, with a contingency table, what we're really looking at is we're trying to answer specific questions, and we're making sure that we understand what the questions are really asking. All right? These are questions that anyone could ask about this table, And you can report them in percentage form or fraction form right now. I don't really care. We're going to do more of this tomorrow. But we're just looking at what's happening. So we got 5 questions that are all very similar in style, but they're all very different in answer. So on 1, what percent of passengers survived? How am I going to find what percent of passengers survived? But how am I going to find that? All right, you have 711 passengers that survived out of 2,201 total passengers. So it's 32.3%. That's not a big deal. You guys can all find that. It says what percent of passengers. It's very clear. It means all passengers. On the second one, what percent of passengers were in second class? So how do I find that one? Right, 285 divided by the total. Because we're still looking at what percent of passengers. So that's 12.9%. What percent of passengers were in second class and survived? Second class and survived is what, 118? Still out of total passengers, because it's still asking out of passengers. So that's 5.4%. Questions about those? Right, you're asking out of total passengers. What happens is when we get into conditional distributions, conditional distribution is just a fancy word for saying that one variable is dependent on another variable. So you're not going to be taking it out of the total anymore. They're going to narrow your population. All right, so it's conditional upon what that population size was. So number 4 says, what percent of second class passengers survived? So what percent of second class passengers survived? So how would I find that one? Yeah, 118 out of 285. Total number of surviving second class passengers out of second class passengers. So 41.4%. And then the last one, what percent of survivors were in second class? What percent of survivors were in second class? Someone said it. Right. Because our population now is narrowed to survivors. So 16.6%. Right? They all have the same words in them, but 5 very different questions. Right? Just be careful what that population is. 2 more questions. Going back to talk about those distributions. If it says, what is the distribution of the classes? I'm worried about the total. Now, you can report that as individual numbers. You can say there were 325 people in first class, and 285 people in second class, and 706 people in third class, and 885 crew members. Or you can report those all as percentages and divide by the total, 2,201. That's what the distribution is. You list each category individually and give that number. Okay? So we handle that. Yeah. The second one, though, is what's the conditional distribution of classes for the survivors. All right? So this time we're looking at the distribution of classes, but it's based on just survivors. So instead of listing the numbers in the total, we're looking at the distribution of classes just in survivors. So we're looking up here. So again, you can report that all out as numerical values. So you can say there were 203 first class passengers that survived and 118 second class passengers that survived, yada, yada. Or you could list it as percentages, but this time we're dividing it by the number of survivors, 711. So 203 out of 711 and 118 out of 711, et cetera, et cetera. When it asks for a distribution, you're normally listing a number for all categories. It's just important to note what kind of distribution you're doing. Does that make sense? Okay. So then what you're going to do today for your assignment is you're going to go through and do some questions about pie charts and bar graphs and that kind of thing that you read about last night. And then at the end, there's an example of this contingency table, conditional distribution stuff. Tomorrow, when you come in, I'm going to give you more of the conditional and contingency table information to do when you get to class. There's 4 of them you can do real fast. All right. and then we'll finish up chapter 3 tomorrow. We're going to talk about segmented bar charts, which kind of puts everything in this chapter together. All right? So you have plenty of time in class to work on this assignment and ask questions. Okay? So here is the assignment.